In rural Cambodia, Project Battambang, led by NUS School of Medicine, provides crucial health services and education to underserved communities. Unfortunately, for the last 13 years, they have been managing this massive operation with just pen and paper. This manual record-keeping system not only slows down note-taking, but is also not scalable and difficult to maintain. Hence, in partnership with the Battambang team, we are creating a digital clinic management system. Then you'll be taken to the welcome and login page. You can use an existing login or create a new user. After logging in, you'll be prompted to choose a location, and that's because our client sets up these clinics in different parts of Cambodia. So every location has a separate database that they have to connect to. Now, this user specifically has admin rights, as you can see, which means that they can go to the admin page and manage the rights of other users. Admins also have access to all the other pages, so that means we can go to the reception and check out the features there. At the reception, the system provides real-time updates on registered patients. Receptionists can edit, add, delete, and filter patient information. At the checkup stations, tried staff can search for patients using the queue number and add records such as height and weight. The system automatically calculates BMI based on patient data and categorizes it using color codes, considering the selected patient's age and sex. There is also built-in type checking and exception handling to ensure accuracy of data sent to the database. Some patients may be deferred from certain tests based on their constraints. For example, adults don't really have to go for dental and head lice screening. Once we are done with updating the patient's record, we can then move him out of the in-progress queue, and we'll see that they appear again in the next station's waiting queue, which is education. Now let's move them to the in-progress queue and update their status to completed education and send them to the next station, which is doctor consultation. Here we can search queue number 36 and view their triage results, and the doctor can actually add consultation notes, condition type, etc. on the right side panel. You can even view history records in a larger panel since it's easier to see, and also view all the records as a text file in general. So this is what the right side panel looks like when the doctor has kind of filled it, and you can also edit prescription in a separate pane where it's easier to see. So the changes are reflected in the front. We can also create a referral and print it as a PDF on the user's machine. So let's update this user and try out the pharmacy. At the station, pharmacists can view the patient's prescriptions, drug allergies, as well as dispense status. A filter and search function helps pharmacists find specific medicines quickly. The system provides warnings if the stock is running low. And pharmacists can also view and search for low stock medicines to manage their inventory effectively. They can also update their inventory on the spot. After dispensing the appropriate medicines, the pharmacist can check out the patient, marking the exit from the clinic. If all these queues sound confusing to you, don't worry, because you also have a queue manager where you can simultaneously move patients between queues. You can also reorder them within the same queue. And these queues actually pull from the database every 5 seconds or so. So if you have multiple users making updates to the queue, you will be able to see their changes. We would also like to share that admins can actually export all the data collected over the day as a CSV file and analyze it after the whole trip ends. Behind the scenes, this is our architecture diagram and the tech stack used in the project. Before building our code base, we paid special attention to the design of the database schema and also maintained an ERD plus package diagram as we continued developing. To ensure that the system is scalable, we stuck closely to object-oriented programming and some of the solid principles. For the next milestone, to improve the quality of our system, we've implemented 3 types of testing: unit, user, and the mandatory developer testing. The unit tests allow us to test the internal functionality of the system modularly, whereas the user tests give us feedback on the UI and UX. Our vision is to provide an efficient and reliable system to the team, enabling them to reach an even larger segment of the rural communities in Cambodia.